And this is AP Stats Quideo number 2, basic question. Here are Professor Moore's times in minutes to swim 2,000 yards and his pulse rate after swimming in beats per minute for 23 seconds in the pool, and it gives us this data. Alright, so A says verify that a linear model appropriately models the data and state the equation of the linear model. So the easiest way to do this is to just take your calculator and enter all the data in list 1 and list 2 by clicking Stat Edit. And I've already got all the data listed. And then next, you're going to go back to Stat and do Calc and scroll down to where it says 8 for linreg, and this will give you the linear regression model. So there's the numbers. A is the intercept, B is the slope, and here is the equation right here. But you also notice on the calculator it doesn't give you r or r squared. To fix this, all you have to do is go to second 0 for catalog, and then scroll down until it says diagnostic on. There. Click that again, it says done, and then go back to Stat, Calc. You can just press 8, and it should give you the r and the r squared there. So, the second part of the question is, does it appropriately model the data? And even though this has a very low r squared, as you can see it's only 0.5564, that's not very good, it's only 55%. All the other models, like the power model and the exponential model, don't do any better. As you can see, exponential regression model has 0.54 and power has 0.547. So even though this doesn't have a very high r squared, it still is the best model for this data. Alright, so B says the next day's time is 34.30 minutes. Predict the professor's pulse rate. His actual pulse rate was 152. So first, to predict his pulse rate, we just have to plug this 34.30 into this equation that we just made. So just plug 34.30 in for the x, and you see that you get 147.39. So the actual one was 152. And the reason that this is pretty far off, or not that far off, but pretty far off, is because of this r squared isn't super high. And then here's just the percent error calculation, which is the predicted minus the actual divided by predicted. And you can see 68.33% error, which isn't very good. That's just because the r squared isn't very high. Alright, C. Suppose you were told that only that the pulse rate was 152. You now want to predict the swimming time. Find the equation for the least squares regression line that is appropriate for this purpose. What is your prediction and how accurate is it? Alright, so to find a least squares regression line, we need to use this equation. Y is equal to b initial plus b1 times x. So first off, we just need to find b1, which is slope, which we can find r times standard deviation of y over standard deviation of x. Alright, it's important to remember that we're switching the variables, so now we're looking to find the time from the pulse rate. So the normal x and y's are flipped, so like, whereas pulse rate would normally be here, you're going to want to put that down here. So you can just use the variable statistics in your calculator to find this data. So click Stat, Calc, and then you can do 2 variable statistics, and just press Enter. And it'll give you all the stuff you need. So we need the standard deviation of x, which as you can see is 0.7286. Now remember, this goes up here, and then if we scroll down to the standard deviation of y, which is right there, 9.46, that'll just go in there. Alright, and then for the r is 0.745, we found that up here. And then once you get this, it's negative 0.0573. And we can just plug this back in the initial equation, and now we need to find this. So we can find this by doing the mean of y minus this b1 times the mean of x. So again, just use this to find the mean of y and the mean of x. There's the mean of y, and there is the mean of x. Plug these into the equation, and you get 43.081. Put this back into the initial equation, and you get your final equation, which is 43.081 plus negative 0.0573x. And then we can put in the 152 and find our predicted, which is 34.37. So this is actually a really good prediction because our prediction is 34.37 and the actual was 34.30. So this is a much better prediction than our first one. Alright, and now for part D. Explain clearly to someone who knows no statistics why there need to be 2 different regression lines for parts A and C. Alright, So basically the reason there needs to be two different lines is because in the first one we have the time and we're trying to find the pulse, but on the second one we have the pulse and we're trying to find the time. So obviously we can't use the same line, and we are just finding the inverse line so that we can use the different variables. And this is AP Stats Quideo number 2 advanced question. To the right are data collected on the prices and capacity of hard drives. Below is the regression analysis for price versus capacity, and it gives us all this stuff. So A, without the use of a calculator, write the regression equation. Define the variables used in your equation. Alright, so remember, for linear regression, the equation is just y equals a plus bx, where a is the intercept and b is the slope. So we come back here, it tells us the intercept is 18.617, and this capacity, this is the slope, so 103.929. So we just plug these in to a for the intercept and b for the slope and get our nice little equation. Alright, B. Explain the meaning of the slope and the y-intercept in context. Alright, so in this equation, the slope is just how much the price goes up per 1 terabyte that is added to the capacity. And the y-intercept is just how much a drive would cost if it didn't have any capacity, which doesn't really make any sense, but it's just what it is in this equation. And for number C, predict the price of a 3 terabyte drive. So for this, we just need to plug 3 terabytes into that equation that we made up here. You see we can do this here and get a nice $330.404. And for D, Shaheen found a 3 terabyte hard drive for $300. According to your regression equation, determine why this either is or is not a good buy. So in the previous question, C, we found out that the price for a 3 terabyte drive should be about $330. So he found one for $300. So this is actually a pretty good deal because he's saving $30 over what the price should be based on our regression equation. This is AP Stats Quideo number 2, AP question. Windmills generate electricity by transferring energy from a wind to a turbine. A study was conducted to examine the relationship between wind velocity in miles per hour and electricity production in amperes for one particular windmill. For the windmill, measurements were taken on 25 randomly selected days, and the computer output for the regression analysis for predicting electricity production based on wind velocity is given below. The regression model assumptions were checked and determined to be reasonable over the interval of wind speeds represented in the data, which were from 10 miles per hour to 40 miles per hour, and it gives us all this data. Alright, so A. Use the computer output above to determine the equation for the least squares regression line. Identify all variables using the equation. So, we can remember that the least squares regression line is y hat is equal to b initial plus b1 times x, where bo, or b initial, is the intercept and b1 is the slope. So here we can come back over here and look and see that the intercept is 0.137 and the slope is 0.240. And we can just plug this in and get our equation. Very easy. And for B, how much more electricity would the windmill be expected to produce on a day when the wind velocity is 25 miles per hour than on a day when wind velocity is 15? So, and then show how you arrived at your answer. So for this, we just need to plug those variables, the 25 miles per hour and the 50 miles per hour, into the equation we just made in part A, and then subtract them. So here we have the 25, and then here we have the 15 subtracted from the 25, and we get about 2.4 amperes should be made on the 2.4 amperes more should be made on the 25 mile per hour wind day than the 15 mile per hour wind day. Okay. And C, what proportion of the variation in electricity production is explained by its linear relationship with velocity? So, for this, we just have to look at the r squared. So the r squared, remember, is how well the line fits the data. So this r squared is 0.873. So we get r squared is 0.873, multiply that by 100 for the percentage. It is 87.3% of the data is explained. And that's it.